Hello students, and welcome to our next presentation. So today we're going to talk about carbohydrates. And with this we're going to start talking about food composition. So we already saw in the past presentation a little bit about the introduction of food science and the role of packaging materials, functions, and so. So now we're going to start with food composition. So as I have mentioned in previous presentations, we can roughly classify food components into two. One is called macronutrients and the other is called micronutrients. So as the words say, macronutrients are the nutrients or the compounds that are present in high concentration in our food or high quantities, and the micronutrients are present in smaller quantities. So let's begin with the first of the macronutrients, which is carbohydrates. So for today, the objectives are to recognize the consumer's interface of a carbohydrate, to list the names for carbohydrates, to describe the function of carbohydrates in our body, to classify the building blocks of carbohydrates, to explain the sweetness ratings for monosaccharides and disaccharides, and to identify the components of fructose corn syrup, and finally to compare the two kinds of browning. Okay, so let's think about the interface of carbohydrates with the consumers. So when we think about carbohydrates and we think about the nutrition facts label, we can see that when we talk about carbohydrates, we can say that it is a sugar, a fiber, or a starch, because carbohydrates is a big group of compounds or molecules, and they encompass all of these three. They encompass sugars, and there's many types of sugars, or what we call sugar, and there's fiber, and we have soluble and insoluble fiber, and then we have starch and different types of starch. So how can we locate the carbohydrates? So here we have the carbohydrates, and we can just draw a circle, and we see here the carbohydrates. So this is a part of the nutrition facts label in which we can locate carbohydrates. So the first one says total carbohydrates, and it says 22 grams, and it's 80% of the daily value. So the daily value for carbohydrates is 275 grams, and this is per day, and it's based on a diet of 2,000 calories. Then we have that inside total carbohydrates we have total fiber, dietary fiber, and dietary fiber is 5 grams, and that's 17% of the daily value. So the daily value for dietary fiber is 28 grams. So in this case, this nutritional label has 5 grams, which accounts for 17% of the daily value. Then we have total sugars, and it's also 5 grams, and we see that there is no daily value. And finally, inside total sugars, we have includes 5 grams of added sugars, and that's 9% of the daily value. And there is a value for added sugars, and the daily value for added sugars is 50 grams. So if we think about we have 5 grams of dietary fiber and 5 grams of total sugars, and that's, if we add them, that will make up 10 grams. But we have 22 grams of total carbohydrates. So what's the rest? So the rest is other carbohydrates that we may not quantify as easy as we want. So the rest can be mainly starch or other compounds that are also carbohydrates. Okay, so let's talk a little bit more about carbohydrates. So because carbohydrates are a group that encompass sugars, fibers, and starch, let's see how different they are in terms of structure. So what we normally call sugar, table sugar, it's a molecule of sucrose. And sucrose is the combination of a molecule of glucose and a molecule of fructose. So as we see from their structures, fructose is a 5-ring monosaccharide and glucose is a 6-carbon ring monosaccharide. And when I say monosaccharide, that means it's what the word mono is like one molecule, right? And this is what makes up sugar and as we know it as a table sugar, and it's sucrose. But there's many types of sugar. We can also call glucose a sugar or fructose a sugar. And we're going to see ahead that there are more types of sugar. But mainly sugars will be one molecule or two molecules. So either a monosaccharide or a disaccharide. And then we talk about fiber. So fiber may be divided mainly into soluble fiber and insoluble fiber, and they have different functions in our body. And this inulin we have here is an example of a soluble fiber. So soluble fibers have many functions in our body, but one of the most important ones is that they are like food for the microorganisms that are in our gut. And inulin has a very complex structure, and this is just part of the structure. And as we can see here, we're not going to cover all the structure, but we have 1, 2, and 3 molecules of fructose, and we have 1 molecule of glucose here. We also can say that this big one is a molecule of sucrose, as we see here. Contrary to soluble fibers, insoluble fibers like hemicellulose or cellulose are fibers that we have to ingest because they help us with our bowel movement, and they're very important for our digestion. So we already saw sugars, fibers, and now let's talk about starch. So starch is also a complex molecule, and it's mainly formed of glucose molecules. So this is a 1 glucose molecule, and then we have another glucose molecule, and so on. And starch is made up of 2 different types of molecules, which are called amylose and amylopectin. And they have different functions in the different types of starch. And we can see here some branches and the way that they are arranged. That will give us many important starch characteristics. But let's move on and talk about what a carbohydrate is. So one rule is that all carbohydrates contain glucose. The other is that carbohydrates are also called hydrated carbons. And carbohydrates contain 3 compounds: carbon, and we can see here the carbon, hydrogen, and we see here the hydrogen, and oxygen, and we can see here the oxygen. And the ratio in which they are arranged is a ratio of 1 to 1. So we have 1 carbon, 2x hydrogen, and 1 oxygen. So let's take an example. For example, glucose. So glucose has C6, so 6 carbons, and then we multiply 6 times 2, 12 hydrogens, and 6 oxygens. And this is the formula for glucose. So there's some like synonyms. So a monosaccharide is 1 saccharide. So a saccharide is also a carbohydrate, and is also called a simple sugar. So why do we need carbohydrates? Why are they so important? So they're very important because they are our energy source. So it's the fastest energy source that we have in our body. And as we mentioned before, all carbohydrates contain glucose, and glucose is what we also called the blood glucose, and also it can be called dextrose. So as we can see, we have these O's. Okay, so when we hear this word, we can associate that we're talking about carbohydrates or mainly sugars, like glucose, fructose, sucrose, lactose, maltose. All of them end in O's. So what are the building blocks of carbohydrates? So if we think the most simple carbohydrates are called monosaccharides. And monosaccharides are glucose, which I have been talking about, fructose. So glucose is what we call, let's say, blood sugar, right? Fructose is mainly present in fruits. And galactose is part of lactose. And we also call them simple sugars. Then if we move one step up, we can find the disaccharides. And disaccharides, as the name says, so two saccharides. So we have sucrose, we have lactose, and we have maltose. We can also call them simple sugars. Then we moving one step, we have the polysaccharides. So poly, it's many saccharides, so many molecules. And these examples are starch and cellulose. So both starch and cellulose are made of different, like many molecules of glucose. They are different because they are bonded with different types of bonds. That's what makes starch easy to digest and cellulose not, and we're not able to digest cellulose. So cellulose is one type of fiber, and we call them complex carbohydrates. So sugars are sweet, and disaccharides are, as we mentioned before, made up of two molecules of monosaccharides. So sucrose is what we call, and we saw in the previous slide, composed of one molecule of glucose and one molecule of fructose. And then we will give sucrose a rating of 1, and that's the baseline. So we're going to compare the sweetness to sucrose. So then we have the second disaccharide, which is lactose. So I'm sure you have heard of like lactose-free milk and so. So lactose is between 0.2 and 0.4 sweetness level compared to sucrose. So between 20% and 40% as sweet as sucrose. And lactose is made up of one molecule of glucose and one molecule of galactose. Then we have maltose. And maltose is between 40% and 50% as sweet as sucrose. And it's made up of two molecules of glucose bonded together. And maltose is the sugars that we get when we do like malting, when we produce beer. So these are the three important disaccharides. So remember, disaccharides made up of two molecules, and they have different sweetness levels, and they are compared to our baseline, which is sucrose. So as we can see here in the pictures, think about sucrose as table sugar, think about lactose as milk sugar, which is also present in ice cream, and think about maltose as the beer sugar. So this is the sugar that we extract from barley to produce beer. So let's continue with sugars that are sweet. So there's a lot of controversy and talk about high fructose corn syrup. Okay, so high fructose corn syrup, which is here, high fructose corn syrup. So how is high fructose corn syrup made? So as we talked about before, sucrose comes, or table sugar, may come from different sources. So one of these sources is cane. So what we call cane sugar. And we can also have beet sugar. But in the US, there's a lot of supply of corn, okay? And corn has a very low amount of like simple sugars because it's mainly starch, so complex carbohydrates. So how can we convert a complex carbohydrate as starch into simple sugar? So if you have tried corn, you may know that it is not sweet at all, because starches normally are not sweet, and they are made up of many molecules of glucose bound together. So when we apply a treatment, and it is called a hydrolysis treatment, we're going to break down the starch molecule into different glucose molecules of different sizes. So we may have a combination of glucose, and then we can have maltose, and we can have oligosaccharides, which are saccharides like 3 or 4 molecules, and we can have also what we call maltodextrins, which are solids that we produce when manufacturing corn syrup. So many different types of molecules. And we may have something like this, the corn syrup, okay? The light corn syrup that we have in the picture here. But if we look closely, it says 0 grams of high fructose corn syrup, right? So once we have our corn that has been hydrolyzed, we get this corn syrup here. It is sweet, but not as sweet as sugar, as sucrose. So then, if we want to make it sweeter, what happens is that we're going to convert all the molecules of glucose into fructose, and we use an enzyme to do that. And that's how we produce our high fructose corn syrup. So first, we have corn, we hydrolyze the starch, we have glucose, different sizes, and then we convert glucose, part of that glucose, to fructose. And we can get these syrups that are not for retail sale, and there's 2 types. High fructose corn syrup 42 and 55. So this 55 has 55% of fructose and is normally used for sodas, beverages. And then we have this high fructose corn syrup 42, which is mainly used for other types of foods. So here I'm going to leave a link to high fructose corn syrup questions and answers. And this is a page from the FDA in which you can check more information. So why do people are so afraid of high fructose corn syrup? In reality, high fructose corn syrup is only corn that has been hydrolyzed, and then the glucose has been converted, or some of the glucose, part of the glucose has been converted to fructose. And this is done because fructose is sweeter than glucose, and that's what we need to sweeten beverages, for example. So let's continue with our carbohydrates. So we already know that we may have sugars, and we may have fiber, and we may have starches in carbohydrates. So let's see here an example of a bread. So bread is a typical example of a food that is high in carbohydrates. So if we see here, for example, we can see that a serving size, so a slice of bread, is 41 grams. And then if we see here, we see that total fat is 1.5 grams, that carbohydrates is 22 grams, and proteins is 5 grams. Okay, so roughly, if we add these 3 macronutrients, we can say that we have 1.5 grams of fat plus 22 grams of carbohydrates plus 5 grams of proteins. So in total we have 28.5 grams. So if the slice is 45 grams, the rest is water. And this is very important. So 16.5 grams are water. But carbohydrates are present in the highest amount. Carbohydrates are around 49% of your bread slice. And if we see the list of ingredients from the label, so this is a 21 whole grain bread we can see there's a combination of many types of flour. So let's go and read these. So we see organic whole wheat. Then we have water, okay? Then we have organic cane sugar. So we have a sugar, okay, here. Then we have organic 21 whole grain and seed mix. And then we have a parenthesis. So they're going to explain how they make the 21 whole grains and seeds mix. So we have flax seeds, we have sunflower seeds, we have many other types of flour, like different types of flours. Like, for example, we have a combination of like triticale, and we have barley, and we have oats, and we have rye, then we have cornmeal, okay? We have spelt, we have brown rice, okay, rice. We have amaranth flour, we have also cornmeal, and we have kamut, which is a Korean wheat. We have quinoa, all of these are cereals. Then we have buckwheat flour, we have sorghum flour, and we have gluten, and we have then many different types of seeds. And then we have other things like molasses, which are also sugars, and we have other ingredients. But if we think about this bread, it's mainly composed of flours from different cereals, and most of the cereals composition is the highest percentage is carbohydrates, mainly starches, and also some percentage of flours and small percentage of sugars, and then a percentage of proteins and a very small percentage of fat. And we can see this in our label. So as we recall, we have 49% of carbohydrates, and then we have around 3% of fat or lipids, which are these, and then we have around 11% of protein, which is these 5 grams. And we're going to see and talk about more about this in future presentations. And I also want to introduce you to these, which are the claims. So these are the claims. We can have nutrition or health claims that this bread is making, and they are located here in this part of the package. So it says 5 grams of protein. We can confirm this in the label. It says 5 grams of fiber. We can also confirm this in the label. It says 250 milligrams of omega-3. And this is part of this polysaturated fat. But we're going to talk about, now we're focusing more on carbohydrates. And it says 22 grams of whole grains. And then we have these for the total carbohydrates. And then we have other claims like USDA organic, non-GMO, whole wheat, and this is like the symbol for kosher. Okay, so all these claims are in this package. So the important thing here is that all of these, or many of these, contain carbohydrates. And carbohydrates are a diverse group of different compounds, and we cannot measure all of it. So what we can measure is fiber and sugars. So let's continue. So we have 22 grams of total carbohydrates, 5 grams of fiber, 5 grams of sugar, and 5 grams of added sugars. And if we wanted to calculate the net carbohydrates, that will be equal to total carbohydrates, so 22 grams minus the dietary fiber, and that's 5 grams. So this is a formula that you guys should know, how to calculate net carbohydrates. So how do we test for carbohydrates? So carbohydrates are difficult to test, and normally we use what we call an elimination method. Okay, and here we can see it says calculation, right? And this is just an example of carbohydrates for a solid food and a liquid food. So carbohydrates are equal to 100 minus the amount of fat minus protein minus moisture minus ash, which is minerals and inorganic materials. So it's similar to what the example I did in the previous slide. If you need, you can go back and check that. I didn't include the ash because I just did a very fast calculation, and ash normally is a very low percentage, but you guys can do it and see how the final result changes. So if we want and we go to a lab and we want to measure carbohydrates, they will certainly be calculated by elimination. They will measure the fat content, the protein content, the moisture content, and the ash content, and then calculate the carbohydrates by difference or elimination. So what happens if we don't want a number like a total carbohydrate number, but we want specific carbohydrates? So let's say we look at this list of ingredients and we have chewy bars and we have 9 grams of fiber. And we want to know if this bar really contains 9 grams of fiber. So we can test for dietary fiber. And as we have seen in previous slides, that is part of the nutritional facts. So there is a test to measure fiber, and that's what we call dietary fiber. We can also want to test for more specific things like soluble fiber or insoluble fiber, or maybe we want to test for more specific, let's say inulin or cellulose. And there's also tests available at different labs, and one example of these labs is this Eurofins carbohydrate testing, and you guys can check the link and see all the tests they have. But we may also want to test, for example, different types of sugar. So let's say we have here corn syrup, and we want to see the composition of corn syrup, like which molecules, what percentage of sugar, of glucose molecules we have. So that's what we call a sugar profile. If we have, say, fructose, for example, here we have sugar, and we want to know percentage of glucose and fructose. But we may also want to see starch composition, and that's a little bit more difficult, but we have here the oats, and maybe we want to test. So there's many analysis that can be done to be very specific about carbohydrates. So one of the important trends is fiber, and many tests are being done to try to figure out how fiber and the different types of fiber affect, for example, our gut and digestion. So as we know, and as we mentioned before, carbohydrates provide energy, and this is measured in terms of calories. And this is what we use to calculate the total calories in the nutrition facts. So 1 gram of carbohydrate will give us 4 calories, and that's a very important rule for you guys to remember. A soluble fiber, 1 gram will give us 2 calories. Insoluble fiber, 1 gram will give us 0 calories because we cannot digest them. Non-digestible carbohydrates will give us 2 calories per gram. Sugar alcohols, about 2 calories per gram, but this may vary depending on the type of sugar alcohol. And then moisture and ash, also 0 calories per gram. So this is very important to remember for our calculations. So can labels hide sugar? So all of this list is like sugar. And so now you guys know there's different types of sugar from different sources. And they have different processes. But all of these are sugars, and they can be a combination of monosaccharides or disaccharides, and they can have different processes, but all of them contain sugar. So let's just look at them very fast. So sugar is sucrose. Maple syrup comes from the maple tree, and it has a specific profile of sugars, agave, from the agave plant, brown sugar. So it's like a less refined sugar, honey from bees. Molasses are sugar that are produced during cane sugar processing. Then we have raw sugar, which is similar to brown sugar. We have cane juice, which is, of course, has sugar, sucrose. Fruit juice, so juices have a combination of sucrose, glucose, and fructose, and because it's concentrated, it has high amount of sugars. Vegetables also have sugar. Corn syrup, we already talked about it, high fructose corn syrup, dextrose and glucose, invert sugar, lactose, malt sugar, fructose, and sucrose. So all of these are sugars. They are a combination. Some of them are monosaccharides, some of them are disaccharides, some of them have a combination of both, and also oligosaccharides. So it's important to understand that all these are, in simple terms, sugars. They have different compositions, different molecules of sugar, but they are sweet and they are sugar. And this is a series that if you want to know more about high fructose corn syrup, you can watch this on Netflix about the story of high fructose corn syrup, and you can have more information about this. And finally, let's talk about the reactions that take place with sugars. So in your book chapter that you have to read, the Sweet Talk chapter 1, we can classify the reactions that take place with sugars into Maillard browning and caramelization. So let's begin with Maillard browning. Maillard browning is a series of reactions that happen in cascade, and they need two things to happen. One is what we call a reducing sugar, and the other is an amino acid. So amino acids, we're going to see them later, but remember this. If you have a reducing sugar and an amino acid, we can have this Maillard reaction happen. And then we have this browning. So browning is the brown color. And we can have this variable browning, Maillard browning in, for example, baked goods. So this will give us the nice brown crust that we like. We can also have it in chocolate and also the flavor of cooked meats. So if we have a sugar, reducing sugar, so reducing sugar is a sugar, you can have it a monosaccharide or a disaccharide that can be broken down. And then we have an amino acid, then we have this reaction. But these may be also undesirable, like dried potato flakes. We don't want them to be brown, or dried egg whites. We also don't want them to be brown, or milk powder. So we have to prevent this reaction. And the second type of reaction is called caramelization. And there's also involves different types of reaction. The important thing is that proteins are not involved. It's only sugars. And that it requires higher temperatures than Maillard browning. And it's what produces the flavor in sugar-containing foods. And it would also give us a caramel colors. So with this, we finish our carbohydrate unit presentation. And this is our first macromolecule. It is very important. We consume it in many types of food, many types of cereals, and then cereals are converted into bread or pasta, crackers. So think about in what type of foods can you find carbohydrates, and in what percentage are these carbohydrates present, and then think about the different ingredients that you may find in the products that you like to eat, and try to classify them into starches, fibers, and sugars. So thank you. See you next time.